In mathematics, linear interpolation is a method of curve fitting using linear polynomials. Linear interpolation between two known points. If the two known points are given by the coordinates and the linear interpolant is the straight line between these points, for a value x in the interval, the value y along the straight line is given from the equation which can be derived geometrically from the figure on the right. It is a special case of polynomial interpolation with n equals 1. Solving this equation for y, which is the unknown value at x, gives which is the formula for linear interpolation in the interval. Outside this interval, the formula is identical to linear extrapolation. This formula can also be understood as a weighted average. The weights are inversely related to the distance from the endpoints to the unknown point. The closer point has more influence than the farther point. Thus, the weights are which are normalized distances between the unknown point and each of the endpoints. Because these sum to 1, which yields the formula for linear interpolation given above. Interpolation of a data set. Linear interpolation on a set of data points is defined as the concatenation of linear interpolants between each pair of data points. This results in a continuous curve with a discontinuous derivative, thus of differentiability class. Linear interpolation as approximation. Linear interpolation is often used to approximate a value of some function f using two known values of that function at other points. The error of this approximation is defined as where p denotes the linear interpolation polynomial defined above. It can be proven using Rolle's theorem that if f has a continuous second derivative, the error is bounded by as you see. The approximation between 2 points on a given function gets worse with the second derivative of the function that is approximated. This is intuitively correct as well. The curvier the function is, the worse the approximations made with simple linear interpolation. Applications. Linear interpolation is often used to fill the gaps in a table. Suppose that one has a table listing the population of some country in 1970, 1980, 1990 and 2000. And that one wanted to estimate the population in 1994. Linear interpolation is an easy way to do this. The basic operation of linear interpolation between two values is commonly used in computer graphics. In that field's jargon it is sometimes called a loop. The term can be used as a verb or noun for the operation. E.g., Resnim's algorithm loops incrementally between the two endpoints of the line. Loop operations are built into the hardware of all modern computer graphics processors. They are often used as building blocks for more complex operations. For example, a bilinear interpolation can be accomplished in 3 loops. Because this operation is cheap, it's also a good way to implement accurate lookup tables with quick lookup for smooth functions without having too many table entries. Extensions. Accuracy. If a CO function is insufficient, for example if the process that has produced the data points is known to be smoother than CO, it is common to replace linear interpolation with spline interpolation, or even polynomial interpolation in some cases. Multivariate linear interpolation as described here is for data points in one spatial dimension. Notice, though, that these interpolants are no longer linear functions of the spatial coordinates, rather products of linear functions. This is illustrated by the clearly nonlinear example of bilinear interpolation in the figure below. Other extensions of linear interpolation can be applied to other kinds of mesh such as triangular and tetrahedral meshes, including Bezier surfaces. These may be defined as indeed higher dimensional piecewise linear function. History. Linear interpolation has been used since antiquity for filling the gaps in tables, often with astronomical data. It is believed that it was used by Babylonian astronomers and mathematicians in Seleucid Mesopotamia, and by the Greek astronomer and mathematician Hipparchus. A description of linear interpolation can be found in the Almagest by Ptolemy. Programming language support. Many libraries and shading languages have a lerp helper function, returning an interpolation between two inputs for a parameter in the closed unit interval 0, 1. Imprecise method which does not guarantee v equals v1 when t equals 1, due to floating point arithmetic error. Float lerp, return v0 plus t asterisk, precise method which guarantees v equals v1 when t equals 1. Float lerp, return asterisk v0 plus t asterisk v1. This function is used for alpha blending, and the formula may be extended to blend multiple components of a vector in parallel.